I teach a large first-year biology course called Molecules, Cells and Genes, and this has an enrolment of around 1,000 students. And I evaluated how quantitative skills are taught within this course. So a proficiency in quantitative skills is essential for being a biologist. And by quantitative skills, we mean possessing an ability to use mathematical thinking and apply statistical methods within the context of biology. The Australian Council for Deans of Science recognises that quantitative skills is important not just in biology, but across the sciences, and has designated this as an essential outcome for graduates. My motivation for evaluating quantitative skills in my first year course is that unfortunately, studies have shown that in biology we're not meeting this outcome. We aren't embedding quantitative skills effectively, and our students aren't leaving university confident and proficient. I developed a usable methodology to map quantitative skills in the curriculum that looks at the pedagogies used to teach them, the number of occurrences students have for learning, and how to show this chronologically. The data is collected quickly and in a manner that's easily shareable. And I completed this work as part of my Masters in Education in Higher Education, supervised by Professor Stephen Marshall at UNSW. I've used it to evaluate not just my own course, but a colleague's course. I've presented on it at a biological sciences forum, and I've had interest from other institutions. So these are the data sources that I consult to identify whether quantitative skills are present or not. So the quantitative skills I was looking for when I piloted this methodology in my course were from a published list assembled in a project at the University of New England, and they identified 43 quantitative skills across their STEM curriculum. They developed this list by consulting with the literature, other sources such as the New South Wales High School Certificate curriculum, and consultation with other STEM academics. So that was the list of quantitative skills that I've used, and as a theoretical framework I used the student-centred race model. The race model categorises a course into 4 components: resources such as lectures, activities, so things students do such as tutorials and practical classes, support materials, and evaluation. This enables me to describe the pedagogy of how a quantitative skill is taught. So this is an improvement on previous approaches to curriculum mapping in biology. So once our quantitative skill is identified, I record details of the occasion for learning. So the race component, the week of delivery, and any other comments of interest. It provides information to me about whether students are simply taught a skill in a lecture, or whether they have the opportunity to practice and develop the skill, whether they get feedback, and how it is then evaluated. And this information is useful because we can use it to inform curriculum design. For example, a colleague used this prior to doing their digital uplift of their course and got valuable information from it. The methodology I developed for mapping quantitative skills allows the data to be collected in a way that can be used in learning design representation. So this means I can see how the student experiences the quantitative skill. So what is the sequence to their learning? And I can present that in a way that's easily shareable. I adapted a method for representing learning design by Sue Bennett of the University of Wollongong and aligned this with the race model. Visual portrayal of learning design is useful as it allows us to communicate complex data in a shareable way that's clear and concise. So for example, when I collected the data on how probability as a quantitative skill is taught in my first year course, by showing it visually, I can see immediately that students first see the quantitative skill or come across it in a lecture. They then have support provided by an online video simulation and worked examples in that. However, it's evident that the students have no opportunity to further practice the skill with feedback, and it's then assessed before they've had that opportunity. I hope this has shown how curriculum mapping is a useful evaluation tool to provide feedback on how a skill is taught across a course or developed within a program. It is also useful for benchmarking courses, such as comparing a skill taught across similar courses within a discipline or between institutions.